I soon had to realize that LHC and the CMS experiment is a global enterprise. We are spanning all time zones of the globe, and the sun never sets for CMS. Grid computing is nothing more than interconnecting big computing farms. Our computing needs are so big that we cannot actually have all the computing at one place. We have to distribute it over the world. What I worked on is a tool for the users which hides the complexity of the grid behind a very simple user interface, which helps the physicist to take his code, submit it to the grid, access the correct data sets they want to access, run their jobs, and retrieve the output. The problems which I encountered during my postdoc were more on the interaction level. You have over 2,000 physicists working for the same project. All those physicists have different ideas, have different ways of handling problems and solving problems.
The so-called window to CERN is so important because we can directly talk to the people who are sitting at the detector control room or sitting here in the CMS center.
The more you know, the more you understand the different problems, the more you are involved in solving it and coordinating the solution of the problems to actually achieve a solution of the final problem and in the end take data and publish physics papers. My name is Oliver Gutsche. I am an application physicist working here at Fermilab for the computing division.
First arrived at CDF, I was trying to explore different options, different projects I can work on. And the part of the experiment that caught my attention first was the trigger systems. Between those two clicks, there are 2 million collisions happen. We cannot store all those 2 million, close to 2 million events per second. We have to filter out and decide out of those 2 millions which few hundred events we want to save. We had to come up with a scheme to design, to commission and test the system totally in parallel. There were moments where we thought we failed. So when you're going through it, it was somewhat painful. But in hindsight, I learned from top physicists, basically, the people who are really good in our field, and they just don't give up. They felt responsible for the postdocs, and they kept finding ways and solving problems, and eventually we overcome the hurdles.
For each person shows up in a different way. Sometimes you have a supervisor who's very supportive. Sometimes you have friends.
You start to understand physics from the other side. As a postdoc and a graduate student, you're doing the work. You're down in the trenches, you're doing, checking things out. You start to realize you get more and more removed from the details of what you're working on, but at the same time you become more and more appreciative of the broader view of what's going on in the field.
What we have is Minerva's back there in front of Minos. So originally it was Minos, and we put in Minerva, and then we had another test stand that was called Argonaut, and now we've got another couple of dark matter test stands. There's Ku in there, and there's Domac. And so there's just tons of great experiments going on down here. And the next one to come in is going to be right here, and it's going to be called Nova.
For neutrinos, there's all sorts of discoveries to be made in the next 15, 20 years. And beyond that, there are other intensity frontier experiments that are going to be coming online. For instance, there's the mu to E experiment, which is looking for conversions of muons to electrons. No one knows how frequently it should occur, and so that's a very exciting experiment to imagine coming online.
I feel like I'm at a real center of the field when I'm at Fermilab.
The ability to be in the thick of things as a postdoc, to lead an analysis group, to explore new opportunities.
We have no idea what dark matter truly is. We have a good hypothesis, and the theory is beautiful enough that it must be true. Fermilab is a national leader in astrophysics. With the Sloan Digital Sky Survey, of course the dark matter experiments, and then other experiments probing either particles or even the nature of space itself.
So I found the environment here to be very collaborative and cooperative, where everyone is looking towards getting good results regardless of which experiment you're on.